Lake Oroville just rose 23 feet mysteriously in complete darkness, and seismic activity is spiking as scientists scramble to figure out what is happening. Not a single drop of rain fell on California that night. No storms crossed the mountains. No dams upstream opened their gates. Yet somehow, 7 billion gallons of water surged up from below in just 4 hours. The sensors went crazy at 2:17 in the morning, and by sunrise, the shoreline had moved 60 feet inland. Benches that were high and dry were now completely underwater. But when scientists tested the water, they found chemicals that should not exist. The chemical signatures prove this water did not come from the sky. It came from deep underground, pushed up by forces no one can explain. Seismic monitors detected tiny earthquakes at the exact moment the water started rising. The dam that nearly failed in 2017, forcing 188,000 people to run for their lives, is now holding back a mystery that could be even more dangerous. Millions of people downstream have no idea what is building up behind that concrete wall. Is this a geological miracle that could end California's drought? Or is Lake Oroville sitting on top of something that is about to crack wide open? December 19th, 2:17 a.m. Pacific Standard Time. A monitoring station on the east side of Lake Oroville logs a reading that should not exist in the real world. The water elevation measures 847.3 feet. Nothing unusual, nothing alarming. But within minutes, the numbers start climbing without explanation. The overnight technician stares at his screen as the gauge ticks upward. 848 feet, 850 feet, 855 feet. He checks the radar. Clear skies across the entire Feather River watershed. No precipitation anywhere. By 6 in the morning, the elevation reads 870.1 feet. A 23-foot rise in under 4 hours. No person working at the dam has ever witnessed such a massive gain in such a compressed window of time. The control room erupts into controlled chaos as staff cross-reference 3 independent monitoring systems. The California Data Exchange Center confirms the impossible curve. Backup sensors validate the primary readings. Even manual measurement tools match the digital numbers within 2 inches. This is not a computer malfunction. This is real. When the sun finally breaks over the Sierra Nevada mountains, field crews rush to the eastern shore to see the evidence with their own eyes. What they find defies every protocol in their emergency response manual. The water line has moved inland by more than 60 feet since midnight. The intake tower, which normally stands surrounded by exposed rock and dry earth, now has waves lapping against its lower platform. Buoys anchored months earlier float in positions that do not match any navigation chart. Park benches that sat 10 feet above the surface are completely submerged. Engineers immediately begin eliminating possibilities. Radar shows no storm systems anywhere in Northern California. No rain has fallen for 3 full days. Upstream reservoirs report stable levels with 0 emergency releases. Seismic monitoring stations detect no landslides crashing into the water. Satellite imagery reveals no debris field, no displacement, no visible surface explanation. The Feather River itself remains flat. Every normal trigger has been ruled out, yet the water continues rising anyway. A senior supervisor scribbles a single note that launches a statewide emergency. The shoreline has moved. This is not a computer error. Lake Oroville is not just another reservoir sitting in the mountains. It is the central artery of the State Water Project, the largest public water distribution system on the entire planet. The reservoir holds 3.5 million acre-feet of water behind a concrete wall that stands 770 feet tall. From this single point, a network of canals, aqueducts, and pipelines stretches from the Sacramento Valley all the way south to the Mexican border. More than 27 million Californians depend on the water that flows through these gates every single day. The farms across the Central Valley receive irrigation allocations based entirely on how high the water sits in this one lake. When Oroville drops, crop production across thousands of square miles gets cut. When it rises, agriculture expands. The wine industry in Napa and Sonoma, the dairy operations in the San Joaquin Valley, the produce farms feeding grocery stores from coast to coast, all of them trace their water supply back to this reservoir. Every foot the water moves up or down represents millions of gallons and billions of dollars in economic activity. The hydroelectric power plants buried inside the dam generate enough electricity to supply 800,000 homes. The turbines spin day and night, converting falling water into energy that keeps lights on from the Bay Area to Los Angeles. If those turbines stop, the state's electrical grid struggles to compensate. If the dam itself fails, the consequences extend far beyond California's borders. To put it in simple terms, Lake Oroville is the beating of California. When this lake acts strangely, the entire state holds its breath. This is not a local crisis. This is a single point of failure for water security, food production, and power generation across the most populous state in America. Engineers describe managing Oroville as walking a tightrope in the dark. One misstep, one miscalculation, one unexplained surge that overwhelms the infrastructure, and millions of people downstream face catastrophic flooding. The mystery unfolding at Lake Oroville is not just about water. It is about survival. The scars from February 2017 have never truly healed for the communities living in the shadow of Lake Oroville. That winter, relentless atmospheric rivers pushed the reservoir toward maximum capacity. Engineers activated the main spillway to release pressure and prevent the dam from overtopping. Within hours, a catastrophic failure began unfolding in real time. A giant crater opened in the concrete spillway, chunks of cement the size of cars tumbling down the hillside. Water roared through the breach, carving away earth and infrastructure that had stood for half a century. Desperate to stop the erosion, operators switched to the emergency spillway, an earthen hillside that had never been tested with actual water. The dirt path immediately began washing away. Engineers watched in horror as the water ate backwards toward the dam itself, threatening to undercut the entire structure. If the emergency spillway collapsed completely, an uncontrolled wall of water would surge into the valley below. At 4 in the afternoon on February 12th, authorities issued evacuation orders for 188,000 residents. It was the largest dam evacuation in United States history. Families grabbed whatever they could carry and fled. Traffic jammed on Highway 70 as entire towns emptied in chaos. Children were separated from parents in the panic. Elderly residents were stranded without transportation. Emergency shelters filled beyond capacity within hours as thousands arrived with nothing but the clothes on their backs. The crisis ended only after engineers released massive volumes of water and completed emergency repairs under impossible conditions. But the fear never left. For Maria Santos and thousands like her, the sound of sirens at 3 in the morning still triggers immediate panic. She remembers running through darkness with her daughter Sophia, not knowing if they would have a home to return to. Trust in authorities shattered that night and has never been rebuilt. When the Gojas started climbing this time without any explanation, those old terrors returned faster than any official statement could calm them. The Department of Water Resources activated emergency protocols before noon. Dam safety teams assembled at the command center. Every section of the concrete wall received immediate inspection. Checklists that had sat unused for years became the most critical documents in the building. Water samples rushed to an independent laboratory arrive in sealed containers marked with chain of custody barcodes. Technicians begin testing immediately, running the samples through conductivity meters and turbidity sensors. Then the chemical analysis results start appearing on computer screens, and the numbers make no sense. lithium concentrations measure 4 times higher than normal lake water. Boron levels spike beyond expected ranges, matching signatures typically found only in deep geothermal zones where underground temperatures reach extreme levels. Rare earth metals also appear in the samples. Analyses indicate this water has been in contact with bedrock deep beneath the surface for tens of years, possibly longer. The chemicals are telling a story that the gauges cannot explain. A second round of testing focuses on isotope analysis, examining the molecular fingerprints of the water itself. The oxygen isotope ratios do not match precipitation patterns from the Sierra Nevada mountains. The mineral compositions reveal formations that only occur under conditions of intense heat and pressure, conditions that exist miles below the surface. The conclusion becomes unavoidable. This water did not fall from clouds. It surged upward from deep underground sources. Seismologists reviewing earthquake data from the previous 48 hours discover a critical connection. A cluster of microquakes registered directly beneath the eastern section of Lake Oroville. The tremors measured small on the Richter scale, barely detectable without sensitive instruments. But the timing proves impossible to dismiss. The seismic activity began at the exact moment the water started rising. Geological maps from decades earlier show fault line systems and rock fractures beneath the lake bed. These natural pathways can connect deep aquifers to the surface. When small earthquakes shift the rock formations, the cracks widen. If the pressure in underground reservoirs exceeds the pressure at the lake bottom, water can surge upward through these newly opened channels. The pathways need only expand by fractions of an inch for billions of gallons to flow. But critical questions remain unanswered. Where exactly is the water entering the lake, and how long will the flow continue? Is this connected to a massive underground reservoir system that no geological survey has ever mapped? Scientists cannot see through solid rock. They can only measure what reaches the surface and wonder what lies beneath. Inside the walls of any earthen dam, an invisible threat can begin without warning. Engineers call it piping. Water finds a microscopic pathway through soil or concrete, and it starts carrying away tiny particles of sediment. The channel widens slowly over time. By the time erosion becomes visible on the exterior, the internal damage can be catastrophic and irreversible. This process happens where no human eye can detect it until the structure reaches the breaking point. Dam safety inspectors at Oroville discover alarming signs during their emergency assessment. Cloudy water emerges from drainage systems built into the dam's foundation. The discoloration suggests sediment is being transported through channels that should be clear. Pressure sensors embedded deep within the structure show readings that do not match normal operational parameters. Some instruments register numbers that have not appeared since the terrifying days of February 2017. The timing feels too precise to dismiss as coincidence. Engineers who specialize in dam failure analysis know this pattern intimately. The Teton Dam in Idaho collapsed in 1976 when internal piping eroded a pathway through the earthen core. Over 2,000 people lost their lives in Italy when authorities ignored early warnings of structural compromise. A dam in Uzbekistan failed in 2020 through the same mechanism. In every case, warning signs appeared early. In every case, officials delayed action too long. The crisis demands independent verification. An outside engineer arrives with no connection to the Department of Water Resources and no institutional pressure to downplay the danger. She orders deployment of high-frequency hydroacoustic sensors that use sound waves to create three-dimensional maps of subsurface water movement. Sensitive pressure transducers are installed along the concrete face and within the deep earthen foundations. The instruments are designed to detect the subtle breath of the structure itself, determining whether water pushes through microscopic cracks in the dam or seeps through porous canyon walls from external sources. But scientific data moves at a human pace, requiring days for processing and analysis. The lake, governed only by gravity and relentless underground pressure, does not wait. It continues its steady, silent ascent, inching higher against the gray concrete every hour. Engineers race against forces that cannot be reasoned with or controlled. Maria Santos stands at her kitchen window, hands gripping a cold cup of coffee she forgot to drink hours ago. She watches as the water line claims another foot of the gravel bank that separates her property from Lake Oroville. For Maria, this is not just a weather event or a technical anomaly. It is a haunting repetition of history. She lived through the 2017 evacuation, that chaotic nightmare when sirens screamed through the canyon for hours. The sound still lives in the back of her throat, ready to emerge at any moment. Her neighbor's wooden dock, once a gathering place for summer barbecues and 4th of July celebrations, now sits completely underwater. Only the top railing remains visible above the churning surface. The access road leading to the local marina is no longer a road at all. It is transformed into a slurry of thick gray mud and debris, effectively cutting off the lower neighborhoods from the main highway. When Maria calls the emergency management line, the voice on the other end sounds polite but detached. They tell her they are monitoring the situation. No official evacuation orders have been issued yet. Maria hangs up and looks at her grandchildren playing on the living room rug, unaware of the danger rising outside. She tells her family they are not going to wait for a government siren this time. She begins methodically packing family photo albums, birth certificates, and heirlooms into plastic waterproof bins. Her trust in local leadership eroded long ago, washed away by previous broken promises of safety. For families like hers, being perpetually ready to run has become a grim necessity of modern life. Go bags sit stacked by the mudroom door. Trucks stay fueled with full tanks of gas, backed into driveways for quick exits. Children know evacuation routes by heart. Further downstream, the ecology buckles under invisible strain. The water turns thick and opaque brown, choked with silt and runoff. This turbidity becomes a death sentence for the local salmon population. Fine sediment coats the gravel beds where they spawn, suffocating the next generation before it can hatch. Even more disturbing, the violent water movement stirs up legacy toxins. Mercury and lead from old mining operations rise from the lake bottom, where they sat dormant for decades. When science cannot provide immediate answers, people construct their own explanations, fueled by fear and the silence from official press conferences. Some believe a massive ancient sea lies trapped deep beneath the Sierra Nevada mountains, a prehistoric reservoir sealed away for millions of years. They say the recent micro-earthquakes were not minor tremors, but the sound of stone floors cracking under immense pressure, finally allowing ancient water to spray upward like a fountain into the lake bottom. That would explain why the water contains unusual minerals and lithium concentrations that do not match historical records of the watershed. If true, millions of years of water could be waiting to surge from the abyss. Other theories point directly at human interference. Persistent rumors describe secret government tunnels being built deep inside the mountains for high-speed transportation or catastrophe-proof military bases. Some say an industrial drill accidentally pierced a high-pressure underground river, and that authorities are covering up the error by presenting it as a natural event. The surge happened at night, when tourists and hikers were not watching. Unmarked military vehicles have been spotted patrolling the eastern arm of the lake, where the water appears most turbulent. The hollow earth water theory has spread on local message boards. Believers think giant pockets of water exist miles wide within the Earth's crust, held in a delicate balance by geological pressure. The weight of the dam itself, holding back billions of tons of water, could finally cause the ground beneath the canyon to snap like a brittle twig. That would be like a balloon popping underwater, forcing everything from below to rush toward the surface. If the ground snapped, the entire lake bed might no longer be a solid floor, but a crumbling ceiling ready to collapse. The most scientifically credible wild theory suggests a volcanic pipe awakening beneath Oroville. Heat signatures in recent water samples indicate something cooking deep in the dark. If a magma pocket is moving miles underground, it could act like a piston, pushing ancient groundwater upward through fissures directly into the reservoir. That would mean the entire mountain range is undergoing violent geological change. As the sun sets over Lake Oroville, casting long shadows across the water, the surface rises another 6 inches. There is no wind, yet the lake remains agitated, boiling with small whitecap peaks, as if something massive is breathing just beneath. The concrete dam has begun to sing, emitting a high-pitched acoustic emission that engineers usually associate with microscopic stress fractures. But this sound feels different, melodic, rhythmic, almost like a heartbeat. 7 billion gallons of ancient pressurized mystery now press against a structure built 50 years ago using the mathematics of a world we thought we understood. No dam in history has survived a surge like this without a clear cause. The question becomes unavoidable. Is this a natural miracle that could end California's drought? Or is Lake Oroville sitting on top of something about to crack wide open? Nature always finds a way to remind us who is really in charge, usually right at the moment we feel most confident in our control. The lake is telling us something is wrong. Are we listening?